All right, so I think this is recording. Let's take a look at these three problems. We want to find the domain and the range for each one of these relations. The domain is always the set of all real numbers, excluding any values that cause division by zero, and excluding any values that cause us to take the square root or even root of a negative number. On the range, we're going to have to either just use experience on what we think the graph looks like versus actually using a graphing calculator. But most of the information that we get from analyzing and determining the range comes from the graph. So let's take a look here at number 12. The domain, well, it's going to be the set of all real numbers excluding any values that cause division by zero. Since we have a variable in the denominator, that possibility of dividing by zero exists. If x minus 5 were allowed to equal 0, that's going to happen whenever x equals 5, so we want to prevent that from happening. So our domain is actually all values, all real numbers except the number 5. If we sketch that on a number line, we are going to exclude the number 5, but all the other numbers, they don't cause us any problems. They do not cause division by 0. And we don't have any square roots in the problem, any radicals, so we don't have to worry about that. So the domain of this function is the set of all real numbers excluding positive 5. So from negative infinity all the way up to 5, or from 5 all the way out to positive infinity. Now, for the range, we're going to go and look at the graph, but I can point out a couple of properties that if we have a fraction that reduces to 0, it's because the numerator is equal to 0. So if a over b equals 0, that implies that a is equal to 0. Well, if we look at the fraction that we have, the numerator is always constant. It's never equal to 0. It's always equal to 3. So I know for certain that the output, I know for certain that y cannot be 0. And I believe that's the only value. I think that we're going to see from the graph that the range, and remember range is y values, which is up and down, is going to be from negative infinity all the way up to 0, excluding 0, and then all the way up to positive infinity. But I'm getting that more from experience. I also know what the graph of 1 over x looks like. I know that 3 is a vertical stretch. I know that the minus 5 is a shift to the right. So there's things that I know that you will know in future skill packets that helps me also to determine this range. Pretty much what you have to go by is to look at the graph. So let's do that. So if we come in and go to this Desmos graphing calculator, and if you graph 3 divided by x minus 5, and if you look up and down here, well, let's start from below. That no matter how far you go down, you can see that this line is going down. So it's coming up from negative infinity. And as it comes up, the y values are increasing, they're increasing, they're increasing, and they continue to increase. But notice how this graph never touches the x-axis. There's never a y-coordinate that's 0. In this portion of the graph, you're always below the x-axis. And then the graph jumps over the x-axis and comes over here, and as y increases, it's going all the way up to positive infinity. So it's exactly what we thought it would be. It's the set of all real numbers excluding 0. So that's what we have over here, and that's what you have to practice looking at and just visually obtaining that by inspection by looking at the graph. Let's take a look at number 13. Number 13 is similar to number 12, but it is a little bit different. For the domain, we always fall back on our definition that the domain is the set of all real numbers, excluding any values that cause division by zero, and also excluding any values that cause us to take the square root or even root of a negative number. Well, I don't have any square roots here, but I do have a variable in the denominator. And so I'm concerned if this value of x ever satisfies this equation, then I'm going to be in trouble because that would cause division by zero. So if I solve this for x, then I see that I do not want x to ever equal negative 9 divided by 2. I want to avoid letting x be negative 4.5. But all the other values are fine. So on a number line, if this is negative 4.5, and this is negative 5, and this is negative 4, then it's all real numbers excluding this value. So my domain is the set of all real numbers excluding negative 9 over 2. Now, for the range, again, I use that property, that idea about fractions, that if a fraction ever reduces to zero, it would be because the numerator. But this numerator is never going to be zero. This numerator is always going to be 8. No matter what x you substitute into this equation, the numerator remains 8. So I know that the y value is never going to be 0. And also, if I look at the denominator, with 2x plus 9, with that being squared, I also know that that's something that's squared is never going to be negative. So in this situation, when we go to the graph, I believe that the graph will illustrate that the range is positive real numbers. And remember, 0 is neutral. 0 is not positive. So when I say positive real numbers, I'm excluding the value of 0. All right, so let's go and look at that graph. So let's turn off the first graph. That's the nice feature of this, that you can toggle these on and off, so you don't have to necessarily delete previous problems. You can go back and turn it back on and maybe look at it a second time. So this graph is entirely above the x-axis. We suspected that because we knew that 8 is always going to remain 8 no matter what the value of x. So that's a positive number. And the denominator, it can never be 0. It's always going to be a positive number. And a positive divided by positive is always positive. So you can see, although the graph, if we zoomed in, we can see that the graph is getting closer and closer to the x-axis, but it never touches it. And you could keep zooming in forever and looking at this, and you can see that it's never going to touch the x-axis. All right. So there's our two answers for number 13. Let's take a look then at number 14. Let me shrink this and give myself a little bit of room. So again, the domain is the set of all real numbers, excluding any values of x that cause division by 0, and excluding any values of x that cause us to take the square root of a negative number. Well, I look in the denominator, and I see both a variable and a square root. So this 3x plus 2, it cannot be 0 because it's in a denominator. And it also cannot be negative because it's underneath a radical. So it has to be strictly greater than 0. Okay? So if I solve this for x, I subtract 2 from each side. I divide by a positive 3. and my domain is the set of all real numbers um, that are strictly greater than negative 2/3. Let me sketch that. Negative 2/3, say that's right there on the number line, and oops, we want values of x that are greater, that are to the right, because anything to the left, it's going to cause us to um, either be 0 or negative. If we plug in negative 2/3, then it's going to be a 0. If we plug in something like a negative 2 or a negative 3, like if you plug in negative 2, 3 times negative 2 is negative 6, and negative 6 plus 2 is negative 4, and we can't take the square root of a negative value. So our domain then is all real numbers that are strictly greater than negative 2/3. Now, for the range, this time we do have a variable in the numerator. And so if x were allowed to be 4, and 4 is in the domain, 4 is bigger than negative 2/3, then that's the x-intercept, because that's when y is going to be 0. So I know that 0 is in the range of this. But when I think about our negative numbers in the range, the numerator is the absolute value. And absolute value is always going to be 0 or positive. The absolute value of a number will never be negative. And in the denominator, we are lazy when we say square root. It's really the principal square root, which by definition is the positive square root. So this denominator is always positive as well. So in the numerator, I have either 0 or positive, and the denominator, I only have positive. That ratio, that division, is always going to result in 0 or a positive number. So my range, and we're going to be able to see this from the graph, this time 0 is in the range, because if x equals 4, y is equal to 0, and any other value of x that you pick, no matter what it is, provided that you're bigger than negative 2/3, it's going to be a positive value divided by a positive value. The only time it's 0 is when x is 4. All right, so there's my domain and range. Let's go and look at the graph and see if the graph agrees with my reasoning. So here, yeah, it's exactly what we thought, that it's coming down here. And remember that you can create a table to plug in values if you hit this gear, this cogwheel here, this settings button, and then this will convert it to a table. Oh, okay. I thought that it would not keep the original equation, so it gives us both the original equation and a table. So yeah, so you can play around with this graphing calculator, and it's going to be a very efficient tool. It's going to help you learn a lot of things. We can see that for values that were smaller, that to the left of negative 2/3, there is no corresponding y value. These x's that have undefined y values, it's because x is not in the domain. We know that if we have negative 2/3, that we'll get a 0. Well, I thought it was, let's go back and look. Oh, I have to be strictly bigger than negative 2/3. So negative 2/3 is undefined. So if I had negative 2/3, plus 0.001. No, it's not letting me do that, is it? I thought this graphing calculator would let us add some value, but it's not. All right. So if I make this greater than negative 2/3, which means like negative 1.9. Oh, my eyes, I do not have negative 2/3. I have a 2/2 there. So how can I, all right, I'm going to delete that. Just going to start over. So if I have negative 2/3, it's undefined. All right. If I have a negative 1.9 divided by 2/3, or divided by 3, that's a little bit bigger than negative 2/3, and that is in the domain and stuff. So I can even carry this out, probably get real close to negative 2/3. And you can see that as I'm getting close, here, let's graph the vertical line x equals negative 2/3 for you to compare it on the graph. Where am I at? Here. X equals negative 2/3. See that black line that's going straight up and down? Well, as you get closer and closer and closer, our graph is never going to touch that black line. And as we get closer to it, look, as I'm negative 1.99999 over 3, because that line is x equals negative 2/3. Look, I'm all the way up at 466. You know, it's getting extremely steep as you get closer and closer to that. So anyway, those values of y are going up to positive infinity. You can see it's coming down here and touching the x-axis and then kind of bouncing off of it, and it's going off to the right. Well, all of those y values are positive. So our answer here agrees with our graph for this number 14. So hey, I hope that helps. Sorry about the awkwardness there of trying to key that table in and not being able to see the numbers and stuff. I'll talk to you later. Bye.